This cube, which is 2 inches on each side, had been seen in a picture before. It was part of the German nuclear reactor project in Garching, Germany, where children were reported to have played with these uranium cubes. A mysterious phone call sparked a decades-old enigma, reigniting a chilling mystery that had remained dormant since World War II. A physicist received a small, dark cube with a cryptic note revealing its Nazi origins. The cube's weight, coldness, and radioactivity hinted at a sinister past. It was one of 664 uranium cubes crafted by Nazi scientists in their pursuit of nuclear technology, but the cubes disappeared after the war. Now, they are quietly resurfacing in unexpected places, raising haunting questions. Where are the rest? Who possesses them? What is their purpose? And why are scientists concerned about them? The cube that started it all was received on a hot August day in 2013. Physicist Timothy Coe, an associate research professor at the University of Maryland, was out for a jog when he received an unexpected call from a longtime friend, who insisted on remaining anonymous. The friend urged Coe to meet him immediately at a nearby parking lot. Intrigued, Coe arrived at the designated location and found his friend waiting beside a car. The friend opened the trunk, revealing a small satchel wrapped in paper towels. Inside was a heavy, dark metal cube, roughly 2 inches on each side. The cube's weight was surprising for its size, and its surface bore a charcoal black hue with small notches along the edges. Alongside the cube was a note that resembled a ransom message, reading, "Taken from Germany from the nuclear reactor Hitler tried to build. Gift of Neininger." Coe, a collector of nuclear memorabilia, immediately recognized the significance of the object. He suspected it was one of the uranium cubes produced by Nazi Germany during World War II as part of their attempt to develop a nuclear reactor. In 1945, Nazi scientists were attempting to manufacture a working nuclear fission reactor. These cubes were part of an experimental setup in Hagerloch, Germany, where scientists, including Werner Heisenberg, arranged 664 uranium cubes in a chandelier-like formation suspended in heavy water to achieve a self-sustaining nuclear chain reaction. Around 700 cubes were used in submerged water experiments. Intrigued by the cube's origins, Coe embarked on a research journey to trace its history. He discovered that the note likely referred to Robert D. Neininger, a metallurgist who had worked on the Manhattan Project. Further investigation revealed that Neininger had once possessed a uranium cube, which he had given to a friend. Coe's quest led him to collaborate with Miriam Hurt, a doctoral candidate at the University of Maryland. Together, they began analyzing the cube to confirm its authenticity and its connection to the Nazi nuclear program. What they discovered next was truly concerning. This unexpected encounter with a relic from a dark chapter in history not only reignited interest in the Nazi nuclear program but also shed light on the mystery of these uranium cubes. Before the bomb, how pre-World War II science discovered nuclear power. In December 1938, a groundbreaking scientific discovery quietly changed the course of history, though its implications were not fully understood at first. German chemists Otto Hahn and Fritz Strussmann were conducting experiments in Berlin, bombarding uranium atoms with neutrons when they noticed something strange. Instead of producing heavier elements as expected, their uranium samples split into lighter elements, such as barium. Initially puzzled, Hahn wrote to his longtime colleague and friend Lise Meitner, an Austrian physicist who had recently fled Nazi Germany due to her Jewish heritage. Meitner, now in Sweden, reviewed Hahn's results with her nephew Otto Frisch, a physicist. Over the Christmas holidays of 1938, the two realized that the uranium nucleus had undergone fission, splitting into 2 smaller nuclei and releasing an enormous amount of energy. Meitner and Frisch published a paper in early 1939 explaining the physics behind Hahn and Strussmann's findings. The world of science, and eventually the world at large, would never be the same. The release of energy during nuclear fission was staggering. Using Einstein's famous equation, equals 2 E equals mc 2 Meitner and Frisch calculated that even a tiny loss of mass during fission could translate into a massive amount of energy. This meant that, theoretically, a chain reaction of fission events could create an explosion more powerful than anything humanity had ever seen. Physicists around the world immediately recognized the significance of this discovery, including Niels Bohr, a Danish physicist. A Nobel laureate brought news of nuclear fission to the United States in January 1939, just as tensions in Europe were rising toward the outbreak of war. That same year, physicists in America began replicating the experiments and confirmed that uranium-235, a rare isotope of uranium, could sustain a chain reaction. If properly refined and controlled, it could also produce more fissile materials like plutonium-239 and uranium-233 than the original isotopes. However, the timing was troubling. Adolf Hitler had already annexed Austria, and Europe was on the brink of war. Germany, home to many of the world's leading scientists, many of whom were Jewish and had already fled, now appeared ready to pursue this powerful new science. A terrifying question emerged among physicists: what if Nazi Germany was the first to build an atomic bomb? This fear led to urgent and secret conversations among scientists, particularly in Britain and the United States. In March 1939, Hungarian physicist Leo Szilard, who had long feared the military potential of nuclear energy, began writing letters to warn governments of the danger. By August 1939, he co-wrote a now famous letter with Albert Einstein to President Franklin D. Roosevelt, warning that Germany might be developing nuclear weapons. Roosevelt responded by creating the Advisory Committee on Uranium, a small government body that would eventually evolve into the massive Manhattan Project. Meanwhile, Britain quietly began supporting its own nuclear research program, known as tube alloys, although progress was slow due to wartime resource constraints. In Germany, the Kaiser Wilhelm Institute in Berlin began conducting research on uranium and chain reactions, led by physicists such as Werner Heisenberg and Kurt Diebner. At first, the full implications and urgency of nuclear research were not fully understood by governments. The science was complex, and the industrial capacity to enrich uranium or produce plutonium did not yet exist. By the early 1940s, however, it became clear that nuclear fission was not just a fascinating scientific discovery, it had the potential to become a weapon of unprecedented power. As Europe plunged into war, the scientific community divided. Some raced to develop a bomb, while others were concerned about the consequences of such a weapon ever being used. In Germany, a secretive and potentially dangerous program had begun, driven by the discovery of nuclear fission and Nazi ambitions. This program was not initially focused on building a bomb, but rather on developing a nuclear reactor. Germany's nuclear program began quietly in April 1939, just months after the discovery of fission and shortly before Hitler's invasion of Poland. Leading the program was Werner Heisenberg, a Nobel Prize-winning physicist known for his work in quantum mechanics and the uncertainty principle. Along with Kurt Diebner and other German scientists, Heisenberg led what came to be known as the Uranverein, or Uranium Club, Nazi Germany's secret nuclear project. While the Allies, especially the US and Britain, would later focus on building an atomic bomb, Germany's scientists initially pursued a different goal: constructing a working nuclear reactor. The idea was that a reactor could produce plutonium, an alternative to uranium-235, which could potentially be used in a bomb. But first, they needed to figure out how to sustain a nuclear chain reaction, an ongoing release of energy from splitting uranium atoms. To achieve this, they required two key materials: uranium as the fuel and heavy water as the moderator. Heavy water, deuterium oxide, slows down neutrons enough to increase the likelihood of fission in natural uranium, which contains only about 0.7% of the fissile isotope uranium-235. This is where the uranium cubes played a role. German scientists created solid cubes of natural uranium, each about 2 inches per side and weighing roughly 5 pounds, 2.3 kilograms. These precisely forged cubes were designed to be suspended in heavy water inside a reactor core. Though not weapons themselves, they were essential components of experimental reactors that, in theory, could eventually produce weaponizable material. In total, 664 uranium cubes were produced. The largest single collection, around 400 cubes, was used in the most advanced Nazi reactor experiment, conducted in Hagerloch, a small town in southern Germany. There, in the basement of a church beneath a medieval castle, the experiment was carried out. Heisenberg and his team built their final and most advanced reactor design. The uranium cubes were suspended by wires in a spherical arrangement and submerged in heavy water, forming a lattice intended to support a chain reaction. However, the reactor never went critical. The Germans lacked sufficient heavy water, partly due to sabotage by Norwegian resistance fighters at the Vemork plant in Norway, and they ran out of time as Allied forces advanced. German scientists dismantled their lab and buried parts of the reactor in a concealed shaft, hoping to keep it from enemy hands. By the war's end, no German nuclear reactor had achieved criticality, and they had not developed an atomic bomb. However, at the time, British and American intelligence feared that Germany might be ahead in the nuclear race. This concern helped drive the launch of the Manhattan Project, an effort that ultimately produced the first atomic bombs, with devastating consequences for humanity. The uranium cubes became relics of Germany's failed nuclear effort. One thing is clear: the 664 uranium cubes were real and created as part of Nazi Germany's attempt to harness nuclear energy for military purposes. But how did one of these cubes turn up in a Maryland parking lot in 2013? Here's where the story becomes more unusual. The Allies did recover the cubes, but some of them later went missing. That leads us back to 1945 and a secret mission to stop Hitler's nuclear scientists before they could escape or continue their work elsewhere. Operation Alsos. As World War II came to a close, Allied forces weren't only fighting on the battlefield, they were racing to secure one of the war's most dangerous scientific programs, Nazi Germany's nuclear project. While the public only learned of the atomic bomb after its use on Hiroshima in August 1945, the effort to develop it had been underway for years as the Manhattan Project. One lesser-known part of that project was Operation Alsos, a mission designed to locate and secure Nazi nuclear research before it could vanish or fall into Soviet hands. The name Alsos, Greek for Grove, was a nod to General Leslie Groves, head of the Manhattan Project. The operation was led by physicist Samuel Goudsmit, a Dutch-American expert in quantum physics, and included scientists, soldiers, and intelligence agents. They followed Allied troops closely through Europe, investigating universities, labs, factories, and bunkers. Their goal: determine what the Germans had discovered about nuclear fission, seize any related materials, and detain the scientists involved. By April 1945, Nazi Germany was collapsing. U.S. forces moved into southern Germany, and the Alsos team followed. In the small town of Hagerloch, hidden beneath a medieval church, they found one of the most important discoveries: the remnants of a German reactor experiment led by Heisenberg. Suspended from a wooden frame were 664 uranium cubes, each about 2 inches wide, arranged in a spherical formation like a wind chime. These were designed to be submerged in heavy water to form a core where a sustained chain reaction might occur. But the reactor was incomplete and had not gone critical, due in part to successful Allied and Norwegian sabotage efforts. The Alsos team confiscated the uranium, dismantled the equipment, and detained key German scientists, including Werner Heisenberg. The uranium cubes were shipped to the United States along with research documents, lab notes, and other materials. Some of the scientists were later held in the UK during Operation Epsilon, where their conversations were secretly recorded in order to assess how close Germany had come to building a bomb. The conclusion: Germany was far from producing a functional nuclear weapon. Its nuclear program was hindered by a lack of coordination, limited resources, political interference, and insufficient urgency. Their understanding of reactor design was also flawed in important ways. With the uranium cubes now in Allied hands and the war nearing its end, attention shifted to the post-war era. But questions remain: what became of the cubes, and why are some of them unaccounted for? After the Alsos mission secured the 664 uranium cubes in April 1945, the blocks, made of natural uranium, were boxed up and shipped to the United States. These materials, dangerous in the wrong hands, initially attracted scientific interest. Some were analyzed as part of the U.S.'s expanding nuclear research program. Scientists studied their structure and purity, examining the German methods used in their creation. A few of the cubes were likely